So let's take a look at simplifying these radical expressions. Okay. Remember, we spent a whole section on converting radicals, that is like the square root symbols, right, to rational exponents, that is like the fraction exponents, and then we also converted from the fraction exponents to the radical symbols and stuff like that. Okay. Remember, right, that like, I'm just going to put this maybe like up in here in this space. When you see like the square root of x, right, that's the same thing as saying x to the 1/2 power, right? If we see something like the cube root of, I don't know, x to the 5th, right, like that, that's equal to x to what exponent? 5/3, right? The 5 is the numerator, the 3, which is the root, is the denominator. Okay, just like that. And so on and so forth. Okay, it's important that we have a good understanding of this because that's going to be our first step in all these other problems that we do. So for example, the directions here are going to be the exact same as we had before. Simplify the expression, but here's the little extra. By writing it using rational exponents, and then use the properties of rational exponents. Assume that all variables are positive, exponents in simplified form should all be positive. Okay, so notice here in this example, and we'll walk through this one here together, and then we'll do we'll actually do one here, but here's an example. You see we have x times the cube root of 2y times the cube root of 4x squared y squared. Okay, so you'll notice that that cube root, it's not really helpful for simplifying. Instead, we rewrite it as to the 1/3 power and to the 1/3 power here, right? So 2y, that quantity, to the 1/3, and then 4x squared y squared to the 1/3. Okay, and then you'll notice since both of these are being raised to the 1/3 power, we can go ahead and just multiply the 2y and the 4x squared y squared together. Okay, so the 2 times the 4 gives us 8. The x squared doesn't have an x in the parentheses to multiply with, so it just stays x squared. And then the y squared multiplies with y to give us y cubed. We still have that x out front as well. Okay, then they distribute that 1/3. So the 1/3, 8 to the 1/3 power gives us the 2. X squared to the 1/3 becomes x to the 2/3, and then y cubed to the 1/3, well, that just becomes y to the 1. So then we can finally multiply that x with the x to the 2/3. This is x to the 1, right? That's x to the 1. And so we're going to add the exponents. 1 plus 2/3 gives us the 5/3. And there's our final answer. Notice we don't need to rewrite that final answer. We don't need to rewrite that final answer using the root symbols. You can just leave it with the rational exponent. Okay? Questions on this one right here? So that's just the extra step here. All we're doing is taking the radical and then rewriting it using rational exponents. So for example, letter B, you see a square root of 64y over a cube root of 64y. Okay, so 64y to the 1/2 over 64y to the 1/3. Now, since we're dividing and we have the same base, both are 64y for the base, right? What can we do with our exponents? When we divide, we should subtract. So we're going to do 1/2 take away 1/3. So let me go ahead and write that up here. 1/2 minus 1/3. Okay. When we go to subtract those two fractions, what do we need to do? We need to change this around. What do we need? Common denominator. So 1/2, what is our common denominator going to be here? 6. So that means I have to multiply this one by 3 over 3 and multiply this one by 2 over 2. So 3 times 1 is 3. 3 times 2 is 6. 1 times 2 gives me 2. 3 times 2 gives me 6. So what is 3 6 take away 2 6? 1 6. So our new power here is just 64 to the 1/6. Okay, and then it has a simplify, which I think I was supposed to show the subtraction here. So whoopsies. That's okay though. Okay, I did the subtraction up here, so that work was supposed to be kind of fit in that little box, which to me way too small. Okay. So then 64 and y are both being raised to the 1/6 power, so we can rewrite that as 64 to the 1/6 and y to the 1/6. Okay. Does y to the 1/6 simplify anymore? It doesn't, right? There's nothing, we can't take the 6 root of y, so we'll just leave that as y to the 1/6. What about 64 though? Yeah, it actually turns out to be 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2, 6 twos does give us 64. So 64 to the 1/6 is just 2. And then there's the y to the 1/6 there. So there's our final answer. If it was like 63 to the 1/6 power or something, you'd leave it then. Yeah, you leave it at 63 to the 1/6. Yeah. Just like, yeah, you leave it like essentially this would be your last step then, right there. But you do want to check these things because oftentimes the numbers will simplify. Not always, but oftentimes they do. Okay, good question, Jake. Any other questions on this one? All right, we'll do one more together, and then maybe I'll have you guys try number 6 on your own here. So let's take a look at number 5. All right, and I'll go to Connor. All right, Connor, if you don't mind here, number 5. All right, we've got, whoops, and we're on, oh no, I just wrote on my pants. Sad face. All right, anyway, page 547 here. All right, number 5. A square root, Connor, is what exponent? 1/2. And so we're going to have x to the third to the 1/2 over, and now what about a cube root, Connor? What will that be? What fraction exponent is that? 1/3. Okay. So first things first, just rewrite those the radicals as rational exponents. Okay. Just like that. And now, Connor, we have a power raised to a power, right? So how should we simplify those? What should we do with our powers there, Connor? Power raised to a power, how do you simplify them? Multiply them, exactly right. So 3 times 1/2 is 3/2. And then same thing here, right? Power to a power, so it's x to the 2/3. Okay, so again, 3 times 1/2, 3/2. 2 times 1/3, 2/3. Okay, great. Well done, Connor. Let's go to someone else here. Let's go to Eve. All right, Eve. So we have x to the 3/2 divided by x to the 2/3. How should we simplify from here? With division, and we have the same base, what should we do with our exponents then? So we want to get a common denominator first. That's not a bad idea. Okay, so what would it be in this case? 6. Very good, yeah. So 3/2 is going to become 9/6. Yeah. And then this will become 4/6. Okay? Now what? So when we divide, what do we do with our exponents? Subtract. Very good. So 9/6 take away 4/6 is what? 5/6. And there it is. Okay, and you're done. Okay, x to the 5/6. Questions on any of that? All right, I want you guys to try number 6 then, please. All right. Now this one's numeric, so you may be able to simplify it pretty far. In fact, you might just get a single number. Who knows? All right, but try number 6 there. Okay, try number 6, please. All right, again, rewrite it using rational exponents and then simplify. Right. Again, if you've got questions or anything, I'll come around and help. having a quiz on this stuff Wednesday or Thursday of this week. Okay? Wednesday or Thursday of this week, I believe. I'll pull down to your teachers and see what they say, but Wednesday or Thursday. Okay. Wednesday or Thursday. Did you guys go over this stuff? Have you guys gone over this stuff? You hadn't heard this stuff yet? Okay. Alright. So we can go over this, I can, since you're in my set class, we can review some of that too. Okay. Do you have any specific questions for me down here? So I'm gonna answer your pencil real quick. So the sixth root, so sixth root of anything is just that something down to the 1/6. That's crazy. So it's a fraction, that's all. So here in this case, it would be x, and then 4 to the 6, which is 1/4. X is the fourth root in that case, because it's 3 to it. Okay, and then you can multiply this upper power. Is that more familiar now?
Yeah.
Okay. Yep. Give me like 30 more seconds here, and then we'll go over this. 30 more seconds, then we'll go over this. Come on now. Okay. All right, AJ, were you able to simplify this at all?
No.
No. Okay. So we have some radicals here, right, which can change to exponents, right? For example, a sixth root is what exponent?
Oh, 1/2.
Well, it'll simplify to 1/2 actually, but it's going to be a 1/6.
Mhm.
1/6. But then because it's a 6 there, but since it's 3 over, it'll be 3 over 6, so it does actually simplify to 1/2. How about this fourth root here? What does that simplify to be?
or 6/4.
6/4, which is then 3/2. Okay, and then how about here?
2/3.
2/3. Exactly right. So we end up with, well, first step. There's my first step I did. Okay, I just kind of rewrote them as fractions, but then AJ did one better, and he also simplified the fractions in his head, which is great. Okay. Now at this point, again, you might be kind of wondering, well, what should we do? Well, what is 16? What is 16 to the 1/2 power? 4, right? We can actually come up with that value. What about what is 4 to the 3/2? Well, what's the square root? What's the square root of 4? It's 2, right? And so we can take the square root, 2, and then raise it to the third power. What about 8? What's the cube root of 8? It's 2 as well, and then we're going to square it. Okay, so let me show you here. So I did these kind of step by step. Okay, I took the 16 that was to the 1/2, made it just 4. All right, and then we have the 4 to the 3/2. Again, the square root of 4 is 2, so I just raise it to the third. And then the cube root of 8 is 2, and then raise that to the second. And so I just multiply this out. 2 cubed is 8, times 4 is 32, and then 32 times the 4 there, it gives us 128 for our final answer. Okay, 128 for the final answer there. Questions on any of that? Okay, so lots of options there. One other thing here, I'll just show this to you. I don't know if it's going to be, interesting or not, but, I'll do it anyway. All right, is you can rewrite all of these, 16, 4, and 8. They're all powers of what number? 16, 4, and 8 are all powers of what? 2. Yeah. So I could rewrite all of these. For example, I could say the 6th root, 16 is 2 to the 4th. So I could say 2 to the 4th to the 3rd times the 4th root of 2, 2 to the 2 to the 6th, right? Because 4 is just 2 squared to the 6th. And then the cube root of 8 squared will be cube root of 2 to the 3rd, because 8 is 2 to the 3rd squared. So I can rewrite all those as powers of 2. Now I know that looks pretty complicated, but again, you just take it a step at a time here. I'll kind of go down like this. Power to a power, we multiply. So it's 2 to the 12. Oops. Goodness. All right, I'll just redo this here. 2 to the 12, like that. And then that's going to be raised to the 1/6 because of the 6th root there. 2 to the 2 to the 6th, again, it's 2 to the 12th. And then to the 1/4 power. And then 2 to the 3 to the 2, so again, 6, 2 to the 6th, and again to the 1/3 power, like that. Again, all I did was just multiply the two exponents there, and then I also changed the roots to be rational exponents. And then we can just multiply the 12 times 1/6 is 12/6, which is 2. 12 times 1/4 is 12/4, which is just 3. And then 2 to the 6 to the 1/3, well, 6 times 1/3 is 6/3, or just 2, so it's 2 to the 2. And then 2 to the 2 times 2 to the 3 times 2 to the 2. 2 plus 2 is 5, plus 2 is 7. It's 2 to the 7th, which is equal to the 128 that we got earlier. Okay. So there's multiple ways to do these problems. You don't have to necessarily go the same path as your neighbor or someone else is doing. But, as long as you're following correct mathematical thinking, then you should be good. All right. So there's that. Questions on any of that? All right. So let's see here. Wow, they have some more. I don't know what the... Oh, I see. Okay. I think I see what they wanted to do here. Yeah. Okay. So the last little thing that we want to be able to do is to simplify then these rational expressions as well. So on the next page, page 548, we're going to look at here. Just scoot over. Okay. So for example here, this 256 x cubed x y to the 7th, we're taking the cube root of that. Okay? And we want to try and simplify that as much as we can. So there's a couple different ways to think about doing this. All right. What they kind of have us do here is to break this thing up into basically like the number and then the variables. Here you kind of see they break them up into two pieces. Okay, which, I guess that can work. Oh man, this is going to be trickier. Okay, so what we'll do here is actually I think I'm going to hold off on this part. For right now. This simplifying. Yeah, I'm going to hold off on that. We'll cover this tomorrow, I think, now that I'm thinking about it. Yeah, we'll hold off on that. So pause that. We'll come back to it. Okay. Instead, what I want us to do, though, is to flip the page to 557, and we'll look at solving radical equations some, and we'll get into that. Okay. So we'll skip that thing. Okay. So, solving radical equations, okay, the question is how can you solve equations involving square roots and cube roots? All right. And so what we're going to look at here is square roots today, and maybe we'll cover the cube root stuff tomorrow. But if you can do square roots, then you'll be fine with cube roots too. Okay. So when solving quadratic equations, right, the stuff with parabolas, remember we learned that the number of real solutions depends on the values in the equation. Some equations had 0 solutions, right, like the line and the quadratic never intersected. Some had just one solution where they just touched, and some had 2 solutions where like the line would go through the quadratic. And how many real solutions does the square root equation have? So in this, we'll just take a look at that here. We'll investigate graphically the number of real solutions for different square root equations. Okay? So remember that you can graph the two sides of an equation as separate functions to find solutions of the equation. A solution is just any x value where the two graphs intersect, right? So for example, if we have the equation the square root of x minus 3, and we want to know when that equals 2. Okay, that's an equation, right? We can graph this left-hand side, we can graph this right-hand side, and then see where the 2 points intersect. So let's go to our graphing calculators here. This is one way we can use to solve these. Okay, we'll do the square root of x minus 3. Sorry, you can barely see that. There we go. Square root of x minus 3, and then 2. Okay, just like that. Hit graph. Ooh, my window's way off there. There we go. So there's the square root of x minus 2, or x minus 3, sorry, and then there's the graph of 2. So how many solutions does it look like this equation is going to have? According to our graph here, how many solutions does it look like our equation will have? One, right? There's 1 point is where they're going to intersect. We know that the square root is going to continue to increase forever. This is a horizontal line, so they only ever intersect at 1 point. So it looks like one option when we solve a square root equation, one option is that we're going to have one solution. Okay? What if we changed our number here, and instead of it being positive 2, what if it was equal to negative 2? So we change that. Now how many solutions does it look like we're going to have? 0. They're never going to intersect. So we could also have 0 solutions in some case. So 0 solution would work, 1 solution can work. Okay? So keep that in mind when we're solving those radical equations. Okay? Could have 0, could have 1. Okay? So let's turn the page here. Doopa-doopa-doopa-doopa-doo. They had us explore a bunch of different kinds of situations and stuff like that, but we're not going to worry about solving for the different situations. We're just going to go ahead and just actually solve some. So let's take a look here. Actually, on the page 559, so not this left sheet over here. We're going to go to the right page over here, and we're just going to take a look at some. Okay? Because of course, we don't always use our graphing calculator. Sometimes we actually want to be able to solve it for, just solve it out. So let's take a look here at letter A. Here's an equation that we want to solve for x. Okay? The directions say solve the equation and check for extraneous solutions. And I'll tell you what extraneous solutions mean here in just a second. So here's our equation right here. Okay. The first thing you want to do when you're solving a equation with a radical in it is to isolate the radical. So you want to get the radical by itself. So looking up here, what's with the radical that we need to get rid of? The 2. And so how should we get rid of the 2? Subtract 2 on both sides. So you can see here's the original problem, and they subtract 2 from both sides. We're left with root x plus 10 equals x minus 2. The purpose of getting that square root by itself is so that we can now square both sides. We square in order to cancel out that square root. So when I square a square root, it just becomes x plus 10. When we square x minus 2, we got to FOIL that out, and it gives us x squared minus 4x plus 4. Yeah, there's going to be some quadratic equations in here, folks, sometimes. Okay? So that's our case here. All right? So when you square that x minus 2, that quantity, remember that's x minus 2 times x minus 2 when you square. So it comes at x squared minus 4x plus 4. Sure. All right? And so then we bring everything over to one side, subtract the x over, subtract the 10 over. So negative 4x take away x is negative 5x. 4, take away that 10 is negative 6. So there's that. And it's equal to 0. So we use that zero product property, factor this thing, right? We need two numbers that multiply negative 6, add to negative 5, so it's negative 6 and positive 1. Set each factor equal to 0, and we get x is 6 or x is negative 1. Okay? And those are two solutions. But if we plug 6 and negative 1 back in to check them, one of them doesn't work. 6 does work. If you plug the 6 in for x and the 6 in for x here, you get 6 plus 10, which is 16. The square root of 16 is 4, plus 2 does give you 6. But when I plug in negative 1 plus 10 is 9. The square root of 9 is 3. 3 plus 2 is 5, which is not negative 1. And so then you throw out the x equals negative 1 solution there. Okay, only 6 is your solution. So you have to check here. I know you're like teachers, probably since you guys first learned how to solve equations, you're like, make sure you plug it back in to check. And you guys were like, yeah, we'll check, but you never really do. Now you need to. Now you need to, because you may have solutions that don't work. Okay? So questions on that process? And I just talked us through it here. So let's take a look at another one here, letter B. Letter B, if you notice, it has two square roots. It's got the square root of x plus 6 minus the square root of 2x minus 4. We do not want the square root at this time, because these things are separated by subtraction. When you have two square roots, you want to get one to one side and keep one on the other side. So we get them one on each side. So here we add that root 2x minus 4 over, like so. Okay? And now that we have a square root on each side, we're going to square both sides. So it'll be the square root of x plus 6 squared and the square root of 2x minus 4 squared. What does this left-hand side simplify to be? Yeah, just x plus 6. The square root and the square cancel. What does this right-hand side simplify to be? 2x minus 4. Exactly right. And wow, they solved that all in one step. That's pretty impressive. I guess you can kind of do it. It would be 10. Right, if I subtract the x over here, it's just going to be x. If I add the 4 over here, it's going to be 10, so 10 equals x. That's what that would be. We got to check it, though. 10 plus 6. That would be 16, and the square root of 16 is 4. Let's see here. 2 times 10 minus 4. So again, 2 times 10, 20, minus 4, 16. The square root of 16 is 4. 4 minus 4 is 0. 0 equals 0. Check, it works, so the solution is 10. 10 is our solution there. It was kind of sloppy 10. Okay, it works. All right, turn the page here. Okay, and we'll do this one here. We'll do this one here together, just to make sure we're okay. So number 6, first thing I'm going to do, I'm actually going to rewrite this using the root. Okay, and then we'll go from here. So, Amanda, what should be our next step here to continue to solve this equation, which we do to both sides? Well, so it is a minus 2, so we're going to add 2, yeah. We're going to add 2 to both sides. Great. Isolate that square root. Well done. So the square root of x plus 5 equals, oops, I'm getting ahead of myself, equals 3. All right, and then Amanda, what should we do now to both sides?
Square it.
Yeah, we want to cancel out that square root, so we just square both sides. Okay, squaring a square root, they just cancel out and leave behind just x plus 5. 3 squared is 9. All right. And then last up here, Amanda, go ahead and finish it off. Minus 5 on both sides, we get x is 4. Okay. Now, we may want to stop here. We may want to say, oh, we're done. But we need to check. 4, plug it in here. 4 plus 5, 9. 9 to the 1/2 power, or in other words, the square root of 9 is 3 minus 2 is 1. Check. 4 works. So we're good to go. We can stop there and solve it. Finish solving it. Okay. All right. You know what? I think we're doing pretty good. So I'm going to have us finish the cube root. We're going to look at some cube roots and then we'll stop. All right? Because I think we can do these cube roots no problem too. Okay. And we'll do an easy cube root and then yeah. Okay. So letter A here. We'll do some harder cube roots tomorrow. Letter A, if you look at this one, right, now we're talking about solving equations with cube roots. It's the same steps. Isolate the radical, okay? Isolate the radical. So we're going to subtract 7 from both sides here. We get negative 2. But now to cancel out a cube root, what should we do to both sides?
Cube it.
Cube it, right? So you raise that cube root of x plus 2 to the third, raise the negative 2 to the third. Cubing a cube root leaves it just x plus 2. Cube of negative 2, remember it's negative 2 times negative 2 times negative 2, it gives us a negative 8. Subtract 2 from both sides, and you get x equals negative 10. Okay, so the solution there is x equals negative 10. Technically, we should check it as well. Negative 10 plus 2 is negative 8. The cube root of negative 8 is negative 2. Plus 7 is 5. And it gives us 5. Check it works. Okay. We're going to skip letter B for right now just because that one's a little bit more work than I want us to have to worry about for today. Tomorrow, we'll focus on that. So let's look at number 8. Okay, this will be our last one we do together, and then I'll give you guys time to start on your assignment. Okay. A good bit of time here, too, which is nice. All right. So last one, number 8. Okay, we want to solve this. I'm going to rewrite it using a cube root because that's what they recommend for us to do in the book here. Okay. Should we go ahead and cube both sides at this point? Should I go ahead and just cube both sides?
Divide by 2.
Right, we want to divide by 2 first. We could actually cube both sides here if we wanted to. I'll show you that in a second after we do that. But let's divide both sides by 2 first, like Greg said. Because typically we want to isolate, get that cube root by itself. Okay. And now what do we want to do to both sides? Cube. We're going to cube both sides. So cube the left-hand side, cube the right-hand side. And we're left with x minus 50 equals, negative 125. Yeah, that's right. And then last step here, add 50 to both sides. You guys got it. Great, great. So we get x equals negative 75. Okay, and again, we can check it. Negative 75 minus 50 is negative 125. The cube root of negative 125 is negative 5 times 2 will give us negative 10. So it works. Let me show you here one thing. We can actually cube both sides here at the very first step. Oops, let me rewrite this here. So let me go back to what I had before. Exactly. So because there's not addition here, because it's not 2 plus the cube root of x minus 50, it's just 2 times, we could actually cube both sides here and it won't be that awful. If I cube both sides at this point, okay, what's negative 10 cubed? Negative 1,000. Yeah, negative 10 times negative 10 is positive 100 times another negative 10 is negative 1,000. And then 2 cubed is going to be 8, and then the cube root cubed is just the x minus 50, 8 times the quantity x minus 50. Okay, which we can then distribute the 8, get 8x minus, and then 50 times 8 is 400, I think? Yeah. And you can add 400 to both sides, so you get negative 600 over here, and then divide both sides by 8. And negative 600 divided by 8, I'm hoping, is negative 75. And it is. Okay, so you actually could do it here because it's a product. You don't really want to cube this if it's like a sum or something like that. Later, tomorrow, actually, we will be doing the sum, cubing some sums, which is a pain in the butt. But at this point, you can actually do it. But it's better to go with what Greg says there. Isolate the cube root, or isolate the square root, and then square both sides. Okay, questions on any of that? All right. So I'm going to give you guys a little bit from the previous section, again, just to make sure we're okay with simplifying those radicals. And then we'll also talk about solving a cube root equation. So, on page 564, I'd like you to try numbers. Excuse me. Try numbers 1, 2, 3. 5 and 9. 5, 9. Yeah, I can use this later. And then on the previous homework, which is page 552, you can do these in any order you want, by the way. I like to try number 7, 9, and 11. Okay. Alright, and I can come around and help you guys too if you get stuck on something.